Hey Becca, what are we learning today?
We are learning about the distance formula.
Today we are going to be finding the distance between 2 points on a coordinate plane. Consider this point as the first point, x1, y1, and our second point is x2, y2. The distance between these 2 points equals the square root of the difference of the x coordinates, x2 minus x1 squared, plus the difference of the y coordinates, y2 minus y1 squared. I want to give you a little bit of background as to how we developed this formula. Imagine a coordinate plane where x1, y1, our first point, and x2, y2, our second point. Now we want to find the distance between point number 1 and point number 2. So I'm going to draw a dotted line connecting those 2 points. We're going to utilize the Pythagorean theorem in order to calculate the distance between these 2 points. We're going to form a right triangle with the 2 points. We know that the Pythagorean theorem tells us that this side squared plus this side squared will give us the hypotenuse squared. So, the distance from this point to the y-axis is simply x1, and the distance from this point to the y-axis is x2. So if I draw this dotted line to extend our horizontal, we have x1 is this distance, and x2 is the long distance. So in order to find the distance on this horizontal, it's simply x2 minus x1. We're going to do the same with the vertical line. If we extend it to the x-axis, the distance from the x-axis to this horizontal is just y1, and the distance from the x-axis to this point up here is y2. So the length of this side of the right triangle is y2 minus y1. If we use the Pythagorean theorem, the bottom side, x2 minus x1 squared, plus this side of the triangle, y2 minus y1 squared, equals, our hypotenuse, we'll call it c squared. This is the Pythagorean theorem. A squared plus b squared equals c squared. Now in order to solve for c, we have to take the square root of both sides. So if we square root this entire side, and we square root the right side, this will end up giving us c, which is what we were looking for, the hypotenuse, or the distance between point 1 and point 2, and that will give us the distance formula. I'm going to go through a few examples now. Consider the first point, 1, 2, and the second point, 7, 9. And we want to know the distance between these 2 points. We can apply the distance formula, where this is x1, y1, and x2, y2. So the distance will equal the square root of x2, 7, minus x1, 1, squared, plus the difference of the y's, 9 minus 2 squared. This is going to equal the square root of 6 squared plus 7 squared, which equals the square root of 6 squared is 36, 7 squared 49, which equals the square root of 36 plus 49, 85, and we'll leave it as the square root of 85. That's the distance between the first point and the second point. Here's another example with 2 points in a coordinate plane. We have x1, y1, 1, 1, and x2, y2, 4, 5. The distance equals the square root of the difference between x2 and x1, 4 minus 1, squared, plus the difference between the y's, y2 minus y1, 5 minus 1, squared. This is going to equal the square root of 4 minus 1 is 3 squared, plus 5 minus 1 is 4 squared, which equals the square root of 9 plus 16, square root of 25, and that will give us 5, which calculated the distance between 1, 1 and 4, 5. What if you had a 3-dimensional coordinate plane? The distance formula stays the same, but we have to consider our z coordinate. Underneath this square root, you're going to continue by adding on the difference of the z coordinate quantity squared. So it's the same exact formula as the 2-dimensional version, it just has the z coordinate incorporated underneath the square root. Here's an example. 1, 2, 3, and 10, 11, 12. The distance equals the square root of the difference of the x's, 10 minus 1 squared, plus the difference of the y's, 11 minus 2 squared, plus the difference of the z's, 12 minus 3 squared. So we just threw the difference of the z's underneath the square root to incorporate them for 3 dimensions. This is going to equal the square root of, and if we reduce it, all of these terms are 9 squared. So this is the square root of 3 times 9 squared, which equals the square root of 3 times 81. And we know the square root of 81 is 9, so we can bring that to the outside of the radical sign and leave the 3 on the inside. 9 square root 3 is the distance between this point and this point. I'll show you one more example in 2 dimensions, but using negative numbers. 3, 5, and -2, -7. We're going to use the same formula, but you have to be careful using these negatives. Distance equals square root of difference of the x terms. So now we have -2 minus 3. x2 minus x1 squared plus difference of the y's, y2 -7 minus y1, which is 5, quantity squared, equals the square root. -2 minus 3 is -5 squared plus -7 minus 5 is -12 squared. And remember, when you square a negative, it becomes positive. So we're taking the square root of 25 plus 144. That's going to be, if you sum those numbers together, the square root of 169. And that's going to give us 13, which is the distance between 3, 5 and -2, -7.
After watching this video, you should now know how to take the distance between 2 points on a coordinate plane. If you have any questions, make sure you leave them in the comments. Give it a thumbs up if you found it helpful, and subscribe because new videos are coming out every Monday and Thursday. See you later!